Now let's dive into aggregating the different groups together so that we can get summary data outside of a single group by operation. What we ultimately want to do is we want to take the data, summarize it, and bring us back to a data frame so we can use all the tools about using conditionals and the other bits that we already understand with aggregated data. And to do this, we are going to use a group by with a combination of 2 extra commands on a single line of code. So what we're going to do is we're going to aggregate by the different variables that we see in a df group describe function. So what we're going to do is we're going to look at the GPA data set a little bit more. So we're going to go ahead and load in the GPA data set. So we're going to go ahead and get that from my faculty website. And once we have that data in df, we're going to begin to aggregate that data together. And I want to explain 3 common ways that data scientists aggregate data together. The first way that we aggregate data together is we aggregate data together using a count. So to do that, we do df.groupBySubject to group all of the data together by the similar subjects, by whenever each group's going to have the identical subject within it. And then we're going to aggregate the data based on a count. So inside the ag function, I'm going to write count inside of quotes. And then at the very end, I'm going to do .resetIndex. And for the purposes of data science in this series, we're going to always reset the index to always renumber our rows 0 through whatever the largest value is, and not use the index as the operation that we're aggregating on. So you're always going to see a combination of 3 function calls used in sequence. You're always going to see group by ag reset index. And in doing that, we are able to aggregate all of the data about a group, because remember, the group is a summary data about a set of similar data inside of our data set. We're going to aggregate it in some way and then reset the index. So one way is aggregating by count. And what count does is it counts the number of records that exists in the data set in that particular group. So what that means is every single row of data counts exactly once. So if we have 2 different sections of courses, it doesn't matter what the data is, we're always going to get the value of 2 because there's 2 rows when we count those rows. The second common form of aggregation is we may, inside this ag function, instead of saying we're going to aggregate by the count, we may aggregate by the sum. So this provides the sum of all the numeric values inside of each variable in a data set. So unlike count, where you're going to count each row exactly once, sum actually looks at the value. And when you look at the value, you're going to determine what the sum of all of the values in that group is and just report that final sum. Often we don't want the sum, but the third form of aggregation is the mean. So we may end up wanting to know what is basically the sum divided by the count, or simply the average, or what Python, we call it the mean. So we have a lot of different ways to aggregate the data by. So what we can do is we now see that we have df of group by subject, ag mean, ag sum, ag count to get different operations, and we can use median, we can use min, we can use max, we can use STD for standard deviation, variance, and a whole bunch more ways we can aggregate data. Basically, any way that you've summarized statistics, Carly, we can use that in Python to get a summary of different groups.
Awesome.
So I want to go ahead and see how this actually works. So I want to go ahead and aggregate the data by count. So in just a single line of code, we're going to write df.groupBy, and we're going to group by the subject. Then we're going to .ag by count, and then .reset underscore index. And this series of operations is going to give us a new data frame that contains summary information about the count of different subjects. So we see.
Yes, that's what I see. I see 163 rows. The subjects are all unique. And for all of the other variables, it gives me the counts.
Yeah, so we have 163 rows. We've got all the different subjects. So we start with AAS for Asian American Studies. And what's at the very end?
The very end is Yiddish, YDSH.
YDSH. So for this data set, I think that's right. We have Yiddish as the very final course. So we have alphabetically every single course group together. And in AAS, how many different, what's the count of AAS for example, the A column?
So all of the counts are actually 179.
So 179 for every single count, which means we have data for every single value there. We have the 179 entries for the year, 179 entries for the number of A's, 179 entries for the number of A pluses. So this just sees how many different rows have data. If any of the rows were missing, we'd see the count being lower.
Yes.
So this is a nicely cleaned up data set that's well structured. And let's go ahead and run this exact same line, but now let's look at what happens when we group by a sum. Sorry, when we aggregate by a sum. We're still group bying subject. We're going to change the aggregation from count to sum. So doing df.groupBySubject.aggSum.resetIndex is, as Carly's going to program this up.
All right, here we go. And when you said that, Wade, I did just notice that the index now still starts at 0 and ends at, in this case, 162 for 163 rows.
So we see 163 rows again, indexed by 0 through 162. So just like the indexes we've seen all along.
Yes.
And the top course, again, because we're aggregating by subject, I'm expecting you to see AAS again.
AAS again. And I have some very large values.
Yeah, so for the year column.
The year doesn't really make sense. It says 360,617.
So 360,000 is what we get for the year, which is really interesting because what we asked Python to do is we asked Python to sum up all of the values. So the sum of, we know there's 179 rows. So it basically took all of the years and summed them up. So that was a sum of a bunch of years. That number is absolutely meaningless in the context of data science. And this is where it's important to really understand what the computer's doing. Because the year of 300,000 way in the future doesn't make sense at all. But we can know that that makes sense that we asked the computer to sum up all those values, and it diligently summed up all the years. But a value of something like the A pluses does matter.
We got 771.
So AAS 100, they had 771?
Yes.
A pluses given. And what's the next subject, just out of curiosity?
The next subject is ABE.
ABE? How many A pluses did the biomedical engineers get?
A plus, they got 315.
Ooh. So there's an interesting data analysis that we could do further. I don't know if ABE courses are harder because they give less A pluses, or maybe there's less of them. So there's a lot of interesting questions I already have by just looking at the sum.
Exactly.
And the one final really common way that people will aggregate data is to aggregate data by the mean, or finding the average of that column. So df.groupBySubject, grouping by the subject, aggregating by the mean, and then resetting the index. And what do we get, Carly?
So now I have, again, my index is 0 to 162, and I have each subject with the average for those columns. So the year for AAS is 2014.62.
So the year, so that's an interesting thing. So the GPA data set actually contains grades going back to the year 2010. So the average year of the grades of all the sections is the data, I think, is 2010 through end of 2019. So that's going to be about right in the middle, about 2015. So that makes a lot of sense for the average, even though that number is not particularly useful. But I am interested in how many Fs. Let's go on the other side of the extreme.
Ooh, yeah.
How many Fs did the average AAS course get?
It's interesting because all of the numbers I can see for F are decimals. So the average for AAS is 0.42.
So that means on average, less than one student failed each section of AAS.
Yes.
So on average, there's less than a student. Oh, how about ABE?
ABE on average for F, we have 0.39.
0.39. Okay, so we see that while ABE doesn't have as many A pluses, its average number of Fs is also lower as well.
Yeah.
So these, by itself, this isn't all that interesting, but these are starting to get really interesting questions that merit further analysis. That is there a big difference between ABE and AAS? How are the courses structured differently? How are the grades given differently? Are there broader distributions that we can look at? And do we want to start to visualize these things? How do we want to nerd out with this data even more?
And in data science, it's interesting because you can ask any question you want about the data set, and hopefully through this series, you're gaining tools to be able to answer them.